My name is Kurt Llewellyn. I'm the director of the Ciongoli Center for Innovation. The center was opened 5 years ago. Prior to that, we had 2 years in sort of a testing phase where we were in a much smaller space. And I'm going to get into some of the things that we host there. These are some images of our space. It's about 2,400 square feet. Very flexible space, so very conducive to all the things that many of you are familiar with in terms of fabrication, prototyping, and design thinking. So, there are lots of words for these spaces. The maker space is probably the most common. Fab lab or fabrication laboratory, innovation centers, design centers, idea centers, STEAM centers, and all of them, whether they have a slightly different bent or a different flavor, they all kind of get at the same thing. And this is really about really prototyping, design thinking, and bringing making into the classroom. So our design thinking process is very inspired, as Chen-Yu mentioned, by a program called NuVu, which is an offshoot of MIT, founded about 10 years ago by 3 graduates of MIT, one from the computer science program, one from the School of Art and Design, and one from the School of Architecture. So our process is very informed by our partnership with NuVu. They are partnered with roughly 20 schools all over the globe. So we're able to actually interact and network with those other students and other schools to see what they're designing and building as well. So what are the tools and the apps? I'm going to try and go through this pretty quickly because it's my understanding that most of you have some familiarity, but some of the basics are things like 3D printing. And, we've got a whole host of 3D printers. We've gone through many different brands over the years. We've been in operation, including our first 2 years, for roughly 7 years. So the price point on those has come way down, and they're very ubiquitous these days. So we've got a lot of 3D printers in our space, and increasingly we've got many students who have their own 3D printers at home. The laser cutter is probably the most expensive and the most highly used in our space. We have a 40-watt epilogue laser that will cut through woods and plexiglass. We use it to do artistic things, but more importantly, we use it to do really specific technical things like build specific robotics parts, or if we're creating product development things, we're trying to design technically for that machine. The vinyl cutter is more of an artistic machine for our sake. We do a lot of signage and things like that. We teach through various courses how to design properly. We have some fashion projects where students have designed t-shirts and vinyl cut those. So the vinyl cutter is just another example of one of those machines. So in terms of software in our space, we start at quite a young age, and we use things like Tinkercad for introductory to design. We move into things like Adobe Illustrator, Photoshop, and other design software. Probably the most powerful software that we teach in our space is Rhino, which is a CAD program for 3D modeling and laser cut design. We do a lot of coding and programming. We're going to get into this when I get to the questions. The younger age, we're doing things like Scratch, of course, Hopscotch. And then as we get older, we're doing things like Code Academy, Hour of Code. And then for specific students who have a real interest in this area, we do individual open innovation projects with things like Python, Arduino, Raspberry Pi, etc. So Edward, actually, when he makes his comments on his experience, is going to talk a lot more about robotics. We teach robotics starting at quite a young age. And we move from things like Lego robotics. And thanks to Edward and Chen-Yu, we've now put our foot into or a toe into the water of Vex robotics, and we're hoping to get into more competitive robotics. But as I mentioned, Edward will get much more into that. So one of the biggest game changers, I would say, in these spaces is this concept of micro or physical computing. So from a very young age, things like a Makey, moving into the Arduino, and then for more advanced learners, Raspberry Pi. It's this idea of the analog world interacting with the digital world and using coding and programming to create devices that allow you to do all kinds of things. There's lots of research and resources on this, so I know that this video will be posted for others. The main thing that I wanted to point out was that when I first got into this, it was kind of mostly in educational technology realms that you would see this. Nowadays, it's much more in the mainstream. Things like 60 Minutes, the New York Times, the Wall Street Journal, The Invent to Learn book, which is kind of our Bible in terms of making inside of makerspaces and tying that to the curriculum, is one of the probably the most valuable resources out there. So into some of the questions in terms of what we're doing in our space. So this first question is actually a wonderful one. And, you know, again, when I started out, it was more of kind of an offshoot, and people viewed our makerspace as something that students would go just to do very specific technical things. Increasingly, we've really started to move our programming into the mainstream classes so that we have math teachers, Latin teachers, Spanish teachers, history teachers, all creating project-based learning units in their own courses that require the use of some of the software and tools that we just looked at. So it really is this integrated approach that takes a makerspace and looks at it kind of like a 21st century library in a lot of ways. And we are, in fact, partnered with our library. So research and then design go hand in hand. But the really important key thing that's starting to happen now is that these teachers are embracing these tools so that it's not just happening as a part of a special or an elective class, it's happening all across of our curriculum. Some of the most meaningful projects are cross-disciplinary ones, where a science teacher might get together with a Latin teacher and they create this experience that allows them to design and problem solve in an authentic and real world way. So this is obviously a big question here. STEAM, of course, the acronym for science, technology, education, arts, and math. And the addition of that A, which is relatively recent, about, I'd say 15 years ago or so, there was a big push in the United States for STEM. And that left out this artistic or creative component. What I love, and what I love about spaces like the Ciangoli Center, is that you actually have this wonderful, wonderful ability to teach technical skills, but more importantly, creative thinking. Because increasingly, we're going to see that a lot of things can be automated, right? And so some of those technical skills are important to know about. But in terms of jobs and where we think education needs to go, it's much more on the creative line of thinking. And so the addition of the A is really, really important. And I think it's what sets apart really well-run makerspaces from those who are kind of just touching on the skills themselves as opposed to the creative endeavors. Secondly, why are U.S. schools encouraged to build innovation centers? You know, I think there's never been a time that the demonstrated need for this has been more acute. We have a former board member and author named Charles Fidel, who is an educational specialist, Harvard trained. He published a book, 21st Century Skills, and he uses the term VUCA, V-U-C-A, which is an acronym for volatile, uncertain, complex, and ambiguous. And he espouses that this is the world into which we're going to be sending our students, and they need to be prepared for that. And certainly at this moment in time, you know, we're experiencing that. And we, I think, you know, in many ways are having to really think outside of the box in terms of the way that we educate our students and the way that we think about schooling. And so that idea of this VUCA world, you know, being something that's far off in the future, I think we can all agree is no longer the case. So I think that's why you see so many schools jumping on this STEAM education approach. So yeah, you know, students can participate in our very specific CCI or STEAM classes, and we offer lots of them. They have to do with things like coding, robotics, and a lot of those things. And I highly encourage that. The students who get most interested in engineering, for example, or programming or robotics can do what we call open innovation. They can kind of create their own coursework and even a collaborative project. I have 2 students who are going to be doing an open innovation. This is an extension of a product that they already began, where they're using an Arduino to capture data about a hockey slap shot. So it's like a sports device that would help you analyze your slap shot, much like you'd see in golf or tennis if you went to get your swing analyzed. And they have a wonderful working prototype, and so they're going to be coming in next year to pursue that. And so there are certainly those opportunities. In terms of outstanding students, the one that I just mentioned is probably the current one that I spent the most time with this spring. Even though we were remote, he was working on that project from home. Others include an 8th grade student who created a dodecahedron speaker. He actually created 2 versions of this. The first was 3D printed. It was a 12-sided speaker, and it was, you know, beautiful design, and it sounded decent. So he went the next iteration. He created a laser cut acrylic speaker, and this one he wanted it to be wireless, and he wanted to have LED lights that went to the music. So it was a long-term project that really took him most of the year. But it was iterative. He had that first example, and then he ended up with this wonderful final prototype, which he's heading off actually to UPenn School of Engineering next year. He went to my alma mater, Choate Rosemary Hall in Connecticut, where that speaker was in his dorm room. So that was exciting, and that's cool to watch sort of our students that come out of our center and where they move on to. The other one that I'll mention briefly was a student who at the time was actually in 7th grade, created a working robotic arm out of 3D printed materials and an Arduino. But the cool thing that he did was he actually connected it to an out-of-the-box product called the Myo, which was something that would sit on your arm, and it would actually read the muscle movements from your arm, and you could translate that into code. And so he actually developed his own code that allowed that to do various things. By the end of that year, his 7th grade year, he had it programmed to do a thumbs up, the A-OK, the peace sign, and I think the hang loose sign, something like that. But obviously, you know, that's again an iterative project that has lots of paths and lots of routes that it could go. And he was in touch quite a bit with the Myo development team because they were interested in sort of learning about you know, what he was up to. I believe he's heading to Dartmouth next year, also probably going to be pursuing engineering. So yeah, as an experienced teacher, how old? This is a good question, and it's you know, I'm going to sort of address these 2 questions. Is it too hard? And I would say no, it's not too hard. We begin exposing students at least to some of these conceptual ideas at pre-kindergarten. Now, obviously, the depth into which we can go is much shallower than what we can do with our 9th grade students, for example, which are our oldest. But there are lots of really innovative ways to get them to start thinking creatively about problem solving. And even our pre-K, our very youngest grade, spends a little bit of time in the Innovation Center. So they're starting to get sort of, you know, interested in this. Interestingly enough, we have an outdoor playground that is really designed towards like creative play. And a lot of that has to do with analog building, the use of things like buckets and, you know, large sticks and wooden objects. So even though we're not getting into some of the technical aspects, we're exposing them to this concept that you can design and you can build to create the world that you want to see. And so that starts at a very young age for us. Most of the work that we do on the more technical end, so we do some Scratch Junior with our kindergarten and 1st grade, and then moving into things like hopscotch and others as they get into 3rd and 4th grade. A lot of that work is actually done in the classroom. So one of the staff members from the CCI would load up a cart and bring that down to the classroom. As they get into 3rd and 4th grade is really where they start to spend more time in our space, and we talk about safety with things like soldering and laser cutters and all of those sorts of things. So, you know, this is a tricky question. Personally speaking, and I watched a presentation by Gary Stager, one of the authors of the Invent to Learn book. You know, he thinks that this ought to be happening from the minute they get into education. So whether that's an analog tool that starts to help teach the concept of logic behind programming and coding, or if it has to do with just building and designing, as I mentioned, you know, I think we have lots of opportunities to do this at a very young age. So yeah, this is an evolving question, of course, for all of us. So we are currently planning to have our students on campus. Our youngest students who struggled the most with remote learning, we're hoping to have on campus every day. So that would be grades pre-K through 4. And then for grades 5 through 9, we're probably going to be looking at some form of blended model. We, of course, have boarding students, and so that's a whole other area. Essentially, we're planning to be flexible for this semester. And I'm really pleased to be partnered with the NuVu program that we've mentioned. They've been doing a lot of remote projects this summer and sending maker kits out to students at home so that they have this ability to kind of be back and forth, whether it's remote or in the classroom. So I suspect that we will have some form of blended approach. And that's sort of changing day by day as we hear from, Governor Baker in Massachusetts, who's kind of the one who's steering the helm. He's at the helm right now for this. But yeah, we're planning on building and designing and making however we have to do that this semester. In terms of suggestions for any of the students out there watching now or as a follow-up, I would say number one, the website instructables.com is a wonderful resource. Thousands and thousands of maker projects, and you can literally just type in your interest. So if you're interested in virtual reality or game development, you can type in, any of those search terms, and you'll have a whole host of projects that you could try. So that's one thing. The second thing is I would recommend, trying to pick up a skill. There's never been a better time to do some online coding classes, many of which are free. Code Academy is a good example. Khan Academy's computer science classes are quite interesting. And there are obviously many, many others. But yeah, thinking about what skill you would want to acquire during these times is a good one. And the last thing I would mention is the NuVu website itself. If you go to NuVu Studio, they have their website where they show projects of students, and you can look at the student gallery there and maybe be inspired by some of the designs and projects that they're working on. And so those would be my major suggestions is, stay busy, learn a new skill, and, really think about how you can spend this time, even though we love collaborative work, there's going to be a lot less of that. And so spending some time thinking about, technical skills that you can acquire during this time is probably my highest recommendation. So I believe that's the final question. And I think we're going to turn things over to Edward Chenyu, if I'm not mistaken.
Sure, but before that, I definitely have a little bit more questions. Maybe.
Oh, great.
Yeah, can you maybe just talk about NuVu more about what kind of classes do you guys have at school? Yep.
Yeah, so we work with NuVu, and in our middle school, which is grades 5 and 6 for us, we essentially use the NuVu software. They have a wonderful platform that's attached to a photo booth that's in our space, so that when students need to take pictures of sketches or prototypes or final products, they come out really high quality and in real time. So we partner with them in sort of technical ways, things like software and the photo booth. In the upper school, we collaborate with them much more sort of from a pedagogical standpoint. So the NuVu approach is actually founded on the architectural studio model for learning. The main founder of NuVu is a gentleman named Saeed Arita, and he was an architect. And when he sort of embraced the way of learning that architect schools use to teach design, he started thinking to himself, man, this is really sitting well with me. I understand things at a much higher level. I wonder why we couldn't do this with other subjects. And essentially what they've done is taken this cross-curricular approach and put it into a design architectural studio model. So every 2 weeks, you essentially have a challenge, a design challenge, and the following Friday, you have to present. And you're presenting in front of, in some cases, MIT professors or MIT trained, folks from NuVu, teachers from our own school or from some of the network schools who are either there or listening remotely as students present, and then they're taking that feedback and synthesizing it. In some cases, we then move on to iterate, and the next 2 weeks would take that. In other cases, we would move on to a new challenge. But it essentially is a process that is very much inspired by the architectural studio model for learning, but taken not just with regard to design and architecture, but taken to an approach that thinks about problem solving in general.
Thank you. So about the NuVu Studio, sorry about that. So I'm at the homepage of NuVu. So which should I go?
Up in the top right-hand side, you'll see like gallery, student gallery.
Yep, student gallery here.
And so essentially, you can look through all of these projects, and every 2 weeks, our students, the NuVu students, and students across the globe who are partnered with NuVu are presenting their work in a way that allows you to kind of see their thesis. What was the problem they were addressing? If you click into any one of those projects, you'll see that there's lots of evidence of what the problem was, what their thesis for a solution, and what their process was. One of the most important things about this way of learning is documenting your process, because many times the design itself might actually be a failure. You might try to do something and fail to do it, but what you learned in the process was absolutely critical. And the beauty of our partnership with NuVu is that they've created a method and software that allows you to document that process along the way without too many hurdles. And so when I mentioned that this would be, inspiring any of the students watching, or adults for that matter, looking in and sort of seeing some of the work that's come before, you're scrolling through, and that mechanical box that you're looking at right there was all laser cut parts and 3D printed parts. And it's really, a wonderful and very technical project that was meant to serve as a kind of a design model for what various linkages could look like. And so, it's some really, really cool, neat projects that are happening across this NuVu network.
Great. So talk about the ideas. We saw a lot of ideas going on here, but so how does a student to come up a good idea? So do you have any suggestion, like how they can target any question or any issues? Because a lot of parents ask us, say, oh, the student doesn't have any ideas. So we ask the students, what do you want to do? And they usually answer, I don't know. So is there a good way to inspire them or to find a good place to come up with good ideas?
Yeah, one of the things that we encourage students to be thinking about is, number one, is there something that you are experiencing that is problematic? One of the first studios we did when we moved into remote learning was just that. It was, given the pandemic, is there something that you found difficult or frustrating? Is there a problem that you could solve either in your home or in your close by area? And so that approach of making it authentic and thinking genuinely about, is there something problematic? Sometimes, especially with students at the younger edge of things, so we're pre-K through 9th, so we don't even go into secondary school. Talking about things that are global can be just too overwhelming. So bringing that down to a localized issue of what is a problem that you're experiencing, and if they say, I don't really have anything, moving that one step further, is there a family member or a friend who you think is experiencing some type of problem or has expressed some frustration with something in the analog world that you could actually affect and impact? And that's, I think, a great starting point, is to have them to think personally before globally. Some of the studios that we eventually introduce have to do with things like climate change and much broader topics. But I think from a starting point, especially if your question, if I'm understanding it right, doing this at home, I think creating that personal attachment to something, you're going to have much more success with your students than you are if it's just some theoretical idea about something that you might design for the future, for example.
Great. So for those projects, are they developed by only one student, or they are doing in groups?
So we love to have it done collaboratively. All of the studios that we run when we're in our actual makerspace, as opposed to remotely, and when we switched over this spring to remote learning, we had a lot of individual projects. We had some students who still tried to collaborate, but obviously it becomes a little more difficult. In an ideal situation, we would always suggest collaboration. And we like 2 people, 3 sometimes is too many. So we tend to try and choose 2 students. The way that we typically do that is we do a classic design thinking exercise where if we've introduced a problem, they've had to come up with as many ideal solutions as they can. And then we start to put up sticky notes on a board, and we partner our students based on interest. And they have to understand that wherever they start, whatever that idea is going to be very different from where they end. And that's going to have to do with how well they're able to collaborate, how well they're able to take feedback and suggestions from the innovation coaches, be those the ones in our space or the ones back over in Cambridge at NuVu. They need to be able to listen and process. You know, one of the things that we talk a lot about is students usually come in and they say, I want to do this one thing, and they have their idea already set. You know, what we're trying to teach through collaboration and other exercises is this concept of, you know, an idea back and forth. And so I think collaboration is critical to this type of work.
So, which means like when you doing teaching at school, every class, when every student have one idea, you have to help them like individually. You cannot really just teach them general concepts and then let them just do by themselves, or
so the way we navigate that is you know, if we had two students working together and they had very disparate ideas about how they wanted to solve it, you know, we would have an individual coach working with each group. We are lucky to have a relatively large staff, and so we really do talk about differentiated instruction. It is not, you know, everybody's going to get the same skill because your project might incorporate different skills. That being said, if we have a project that it looks like most of our students are going to need Arduino, we will come in and do what we call boot camp, and we'll do some basic instructional tutorial days where they're getting technical skills, or we might do that by video, right? We might have them actually go and watch some of the tutorials that NuVu or our own folks have prepared, and, you know, kind of create a way for them to get some of the technical skills that's very specific to their project. So one of the things that we are very open to is if a set of students, or, you know, if a duo of students had completely different ideas, one approach, given their personality, might be, okay, let's try both. Why don't you go and come up with a prototype for what you're talking about? You come up with a prototype from what you're talking about. And they bring that together, and usually that resolves in either, oh, that one looks like it's got more feasibility, you know, or, you know, they both sort of see, oh, what if we combine those things? So a lot of this has to do with individual coaching and instruction in the space.
Great. Well, wonderful. Okay, so maybe for the last question, we all know like Fessenden actually a boys' school, but do you have any suggestion like how girls can do this STEAM like a learning or innovation project?
Absolutely. A lot of our summer programming, which unfortunately was canceled this summer, is co-ed. So I do have experience working with boys and girls in our space. And, you know, especially at some of those younger ages, one of the things that I tend to notice with some of the girls in our space is they don't have a lack of coming up with ideas. You know, when I pose to them, do you have any ideas in terms of being creative? You know, when I've worked with middle school girls in particular, you know, they tend to have lots of ideas. So I think that's a wonderful asset that they bring into that space. But the NuVu programming, all of the programming, and the vast majority of the schools that they're working with are co-ed. So the fact that we happen to be, you know, an all-boys school is certainly not indicative of the fact that, you know, we think that STEM or STEAM is a boys thing by any stretch of the imagination.
Cool. All right. Perfect. So any other questions? So Edward or Dr. Tai, do you have anything you want to say? Good. All right. So thank you very much.
Yeah, thank you, Chen, very much for that. And thank you, Mandy, for putting this together. I look forward to hearing from Edward as he talks about his experience, but thank you so much.
Yeah, so I'm gonna stop sharing on my side. Edward, if you can share your presentation, and then let's hear about your story.
Yep. All right. Thank you, Mr. Liu, for that wonderful presentation. I will definitely look into the websites later on, and I encourage you to check it out too. Now I will speak about my experience in robotics and my journey over the years. Okay. All right. Okay. All right. Hi everyone, my name is Edward Yan and I'm going to the 8th grade next year at the Fessenden school. I got into Vex Robotics when I was in the 1st grade. I was 7 at the time and I wanted to try something new. So I decided to look into robotics. Not long after, I discovered Vex. The game for the 2013-2014 season was Toss Up. I joined during the off season for the 2014-2015 game, so I observed many teams building their brand new robots. The game Skyrise was so fun and exciting that I decided to take classes immediately as the new season began. I joined a very good team in China. They had gone to Worlds several times and had won lots of awards in all those years. I was the new kid and my older teammates didn't mind. They helped me realize that everyone on the team is equally important as one another. I first started as an assistant who helped carry robots and different tools when they needed it. The team supported me a lot as I was the youngest one there. They took care of me and gave me jobs to do. That inspired me to not only help people discover their passion and interest in robotics, but also guide them through their technical journey. I learned that robotics can make people's lives easier. For example, taking over jobs such as manufacturing bottles or different clothes. They can also prevent more people from getting hurt in wars and jobs that require more physical movements. Also, robots can help in many different ways for the coronavirus pandemic that we're in today. They can replace people when delivering food and drinks to the patients in the hospital to prevent spreading of the virus. Every day we use robots and technology for our own conveniences. For example, cars, coffee makers, computers, phones, etc. These basic everyday items can replace the difficult things that people do every day. That's why I want to work hard to make a change in the ways that people see technology. I started my own Vex Robotics team in Lexington in 2016 because I wanted to show people that robots and coding can be really fun. Some people might think that coding is boring and engineering can be really exhausting, but you can learn a lot from it, as I did. My problem-solving skills ascended as I worked with my teammates to solve difficulties when it came to building and programming the robot. These skills helped me overcome problems in many ways. Since I started robotics, I've noticed that my math skills have also gone up. And that's another way that we can benefit from robots. That was the first Vex Robotics Club in Lexington, and it started in our basement. The first team was for the 2017 game in the zone. I had just recruited several kids from around Lexington, and we eventually made a website that helped our team to be heard. Over the course of the season, we had issues within our own team, arguing, teasing one another, and worst of all, not working together. One time, we were in an incredibly hard match. It was also a very important competition. One of my teammates was saying that he should drive for that round, claiming that he was better at controlling the robot. My argument was that he already drove last round, so I should have a turn now. Although he insisted on driving, I didn't listen. During that time, I was selfish and I only thought about my own status. I didn't think about his feelings or that his driving skills were indeed better than mine. Even though we fought, after a while we came up with an agreement. He would drive this match, and I would drive the next one. Fighting not only makes things worse, but it makes the bond of the team weaker with each argument. Forward to the off-season of the 2018-2019 game, we had expanded our team from 3 people to 6 people with 2 teams. We did various activities to get people to notice us. First, we made a website. Then we took it a step further and began to start fundraisers for the future field and game supplies. Later, we held a speech at the public library with Pascal from Walsh Middle School. There, I spoke about inspiration and my own experience with robotics. I also talked to them about how important technology is in our lives and how robots can make that happen. That inspired the students to start another robotics class here in Lexington. I felt I had a great impact on society and how my contributions led them to do more things that they love. In the 6th grade, I came to Fessenden and I met Mr. Liu. I felt like I should bring some of the things that I love into the school community. So I thought of Vex Robotics, how it changed my life and my attitude toward other people. So I asked the teacher in charge of the club. He suggested that I talk to Mr. Liu, the head of the CCI, which is extremely cool. It has different 3D printers, laser cutters, and various woodworking supplies. He encouraged me to propose the club during a morning meeting. I was nervous, of course, thinking people might laugh at me. But the entire middle school and the teaching staff was listening. Soon, all of my worries melted away. Later, I got the notice that my club had been admitted into the group. In the next few days, I asked my friends if they would be interested in participating in my club. Although other clubs attracted many people, I didn't give up looking for team members. Eventually, it was Mr. Liu that had recruited many kids that were immersed in STEAM or robotics. Many teachers gave us full support as we went well with the courses, and my friends learned many things about robotics. I was told by the club admission team that my club was a success, and they would allow me to manage it one more year. That was great news. It meant that I could help new students recognize the fun in building and programming the robots. This year, as I moved into the upper school, it grabbed more and more people's attention and gave the club and I a boost of confidence, such as building more advanced robots and brainstorming for the new season. Yes. Through all of these adventures, it was Mr. Liu that had helped me recognize that a lot of people are interested in robotics. And my club gave him the chance to learn something new and to try out this fun, yet challenging activity. In conclusion, I would like to become the STEAM Education Ambassador in Lexington to inspire more local and online students that learning STEAM is really cool. Robotics is one of the best ways to experience this because you're going to learn all kinds of fun activities by doing it, such as building, coding, brainstorming, drawing, and driving. Furthermore, you can also gain hands-on experience like problem solving, leadership, design, innovation, and even presentation skills from doing robotics. It's an unforgettable experience, and I will benefit from it forever. I hope everybody can give it a try to see how cool it is. Thank you. All right.
Okay, thank you very much, Edward. Great talk. So yeah, that's pretty much for today's seminar. If any of you have questions, you can post it in the chat or Q&A section. We're gonna answer it because we still have a little bit of time. If you don't have any questions, we probably can wrap up. So in the end, I'm gonna talk about our organization a little bit more in Chinese. So 大家好，感谢大家参与我们这个今晚的演讲。也希望大家如果有什么问题，可以在这个 chat 里边或者这个 Q&A 里边去来提问。我们也是Vinci 机器人俱乐部也是在麻省这边是专注于VAX 机器人教育的唯一的一家俱乐部。现在我们提供一些在线的课程，主要是教授programming 就是编程的课，或者是一些低龄的孩子来去做上手的一些活动。等到开学了之后，我们应该也会开设一些线下的课程，就像是课后班，还有周末的一些课程。如果就是疫情这个稳定之后，我们肯定还是希望能让所有的孩子来线下做这个机器人的这些活动。另外我们也会今年也会继续参加这个机器人的比赛，也有更多的线上的比赛，他们VAX 官方推出了一些，而且明年的世界大赛也会照常进行，而且会有更多的队伍有机会进入到世界大赛去。 可能在中国的朋友，可能就没办法参加，就来美国参加世界大赛，但是他们也会提供一些这个线上的一些比赛的内容。所以如果大家没有什么问题，那么就感谢各位来宾，感谢我们2位演讲者，然后祝大家能在这个艰难的这个时刻可以度过这个时期。Oh, there's a question. So let's see. So instructable. Actually, I can share my screen to talk about that. So instructable, I think is called is that this? Yeah, this one. Instructables. So this is a website that Mr. Llewellyn just talked. And I send it in the chat. So this website is pretty awesome. They basically, everyone can share any works here. It's just like a social media for makers. It's including all the topics. If we click this projects and the category, there's like a different categories. You can see many stuff, many interesting stuff. And if you click in any projects, you can actually see how the person actually developed the projects step by step, pretty much. You can actually repeat those steps and to create the same thing as you have, as they have.
Can I just add something, Chenya?
Yeah, sure.
So yeah, one of the great things about Instructables is that they typically have materials lists. So they're very specific about what would be required. And obviously some of these projects do require things like 3D printing and laser cutting. So, you know, if you don't have those at home, which many of us of course don't, you know, you might pick projects that are a little more DIY, but it's great because like you say, it's step-by-step with materials lists included.
Yeah. So yeah, I definitely like this one, and also they have some very very hard projects, very fancy but very complicated projects. I think some people use years to develop something and they post it here, and it's pretty awesome.
The student that I mentioned, his name was Charlie Schlager, who did the dodecahedron speaker. He actually posted his project on Instructable, so you can see his instructions for that. It's dodecahedron speaker, DOD. That one requires laser cutter and 3D printing, so it's probably not the best example, but he put a lot of hard work into putting the instructions up there. But yeah, to your point, they're very explicit, and they're relatively they can be very simple and they can be extremely complex. So kind of figuring out what your, you know, for the students listening, figuring out what your own skill set is and picking a project that's in there. I'm sure you can find one that's appealing to you.
When will be the world championship, wax competition? So it usually happens every year around in the end of April. So the end of April's week is the world champion week. It's usually 7 days. Depends so there's 4 days for the wax EDR, which is a high schooler and middle schooler and a university competition teams do the competition, and 3 days for wax IQ, which for elementary school and also middle schools. So this year, unfortunately, the world champion canceled, but wax already said next year they're gonna do the championship for sure, but maybe in a different way, a slightly different way. So yeah, so basically, definitely a good opportunity to join the competition to learn the robotics through WAX. Okay, so our organization gonna start build the teams from September. So we already have like 3 teams from last season. 1 high school teams and 2 middle school teams. And this year we're gonna build 2 or 3 WAX IQ teams, which for young middle schoolers and older elementary kids. And also we may keep the 3 high like WAX, like EDR, the higher level teams for this season. We already started to build the robot, but because we couldn't really open our classroom to public now, so we just do it like privately right now. But definitely from September, we want to reopen our classroom and to have more kids to come. I think also for CCI, they also gonna have the field open and do the like buildings over there, right?
Yeah, we're hoping to have the field up and running. Actually, the field is already up and running last year, so we'll have to modify it, I'm sure. But that's the hope, you know, and depending on what our regulations require for us, you know, we'll have to modify and perhaps have fewer students and doing it at a time. But we're really looking forward to expanding our role in VEX robotics, as well as the IQ, because obviously we have younger students.
Yeah. I also heard that you guys have like a new space for
that's probably for the following fall. But yes, we are currently, we have plans underway for a new science center. And the science center actually is a more ideal space because we could be building with robotics in mind. You know, housing the field in our space was fine, and I love doing it because I was learning from Edward and you all. But you know, our space is really about design and that sort of thing. So we think moving the robotics ring and a robotics space over to this new science center is the way to go.
Okay. Thank you. So yeah, for our robotic teams, we're gonna do like a membership, like a style. So if you join our team, you're gonna join the whole season, and you can come anytime when you have time to like work on your robots, to practice. And we're also gonna invite some local teams to practice together, to share the good ideas. We have a lot of like good connections locally, and to share very good insight about this competition. Yeah, so yeah, definitely if newcomers can join our current teams, we have some older members can like lead the team, but definitely we need more people to join our team to compete, because this is not really a one-person job. It's like you require at least 4 people to compete, because there's like people need to build the robot, people to like to program it, and people to like record the result, develop the new strategies. There are so many roles we can do. Also, there are people need to do the marketing, to do the fundraising, also do some like build a website to show off our like robots. That's all the things. If you YouTube search VEX robotics, you're gonna see a lot of teams post their fancy robot designs online, and it's very, very professional, like produced. It's very cool. Okay, so that's about the time as well. So if there's no other questions, thank you everyone for joining. Hope you guys have a great night. And if you have any questions, you can also ask in the WeChat group. And also you can call us and visit our website. We're gonna post it later. Just hope you see you guys to join our competition teams and do the robotics together. Thank you very much. See you.